Hello, I Abhinav
And I, Sahil Kumar.
are going to present our presentation on the topic design and comparative analysis of MOSFET based and piecewise based DC-DC LLC converters. So, first we are going to give a brief overview of DC-DC converters and LLC converters. Then we will describe the topologies for MOSFET based DC-DC LLC converters and piecewise based DC-DC LLC converters. So for both of them, we will present the design considerations, and for their performance analysis, we have taken four factors: their efficiency, transient response, switching frequency, and EMI, and the last one, component stress and reliability. And then we'll present our conclusion for the findings that we have done for both the topologies.
Now, I start with the introduction. In this presentation, we will delve into the design and performance evaluation of two distinct implementations of LLC resonant converter, the MOSFET based and the piecewise based. We will explore the underlying principles, design considerations, and operational characteristics of each converter type. By conducting a comparative analysis, we aim to gain valuable insights into the strength and limitation of both designs, shedding lights on which converter might be better suited for specific applications. Our finding uh, could pave the way for more efficient and sustainable power conversion solution in various industries, for renewable energy system to electrical vehicle and beyond. Now, overview of DC-DC converters. DC-DC converters are voltage regulators used in power electronics that transform and regulate direct current voltage level efficiently. The switching of semiconductors device control the energy flow between input and output circuits. Two type of DC-DC converters include burst, boost, buck boost, flyback, forward, push-pull, and full bridge converters. The buck converter step down the output voltage, while the boost converter step up the output voltage. Buck boost converters can step up or step down the output voltage. Flyback and the forward converters used transformers for energy transfer. The push-pull and full bridge converters offer higher power handling capabilities. The DC-DC converters provide efficient voltage transformation and compact size. They are enable precise control over put voltage and the current. However, the converters offer isolation capabilities in certain topology. The DC-DC converters are used in portable device, renewable energy system, automotive electronics, industrial automations, communication, aerospace, and more.
For the introduction to LLC converters, they are widely used in power electronics, and for LLC it means inductor, and capacitor. So they operate on the principle of resonant switching, where switching elements are synchronized with the resonant frequency of the tank circuit. Also, they offer high efficiency, especially at high loads due to reduced switching losses. Also, they exhibit low electromagnetic interference compared to conventional converters, making them suitable for applications with strict EMI requirements. Also, they are able to achieve soft switching, reducing voltage spikes and enhancing component reliability. They can accommodate a wide input voltage range, making them versatile for various power sources, and they allow for high power density, enabling compact and lightweight converter implementations. And for their uses, they are utilized in data centers, telecom power supplies, renewable energy systems, electric vehicle chargers, and other applications. MOSFET based DC-DC LLC converters. So this is a type of LLC converter that uses metal oxide semiconductor field effect transistors as the main switching device. It leverages the fast switching speed and low on resistance of MOSFETs to effectively control power flow through the resonant tank circuit, and they act as primary switches, and their switching is synchronized with the resonant frequency of the tank circuit to achieve soft switching and reduce switching losses. And uh, it is known for its high efficiency, making it suitable for high power application, and careful selection of transformer parameters, capacitor characteristics, and MOSFET ratings is crucial while designing.
So now the piecewise based DC-DC LLC converter. The piecewise based DC-DC LLC converter is a variant of LLC converter topology that introduces an innovative switching approach. In this design, one of the main switches in the traditional LLC converter is replaced with the multiple smaller switches. These smaller switches are operated in piecewise manners, that is, they are switched on or off sequentially. The piecewise operation of switches aim to reduce switching losses and enhance the overall converter efficiency. By distributing the switches duties among multiple smaller switches, the stress on the individual switches is reduced, leading to improved reliability. The piecewise converter leverages the advantage of both series and the parallel switching, enhancing power efficiency. Careful control of piecewise operation is crucial to ensure the proper switching timing and to maintain resonant condition. This design is particularly suitable for high frequency application and high power system.
Now we are going to start with the design considerations. First, the MOSFET based LLC converter. So in this, we have selected the Microsoft MOSFET with appropriate voltage and current ratings for efficient switching. We have considered switching and conduction losses as well as thermal characteristics. For the control design, we have implemented techniques such as frequency modulation or pulse width modulation to achieve the desired performance, and the implementation of soft switching control techniques is implemented to reduce voltage and current stresses on component and enhance reliability. The optimization of the converter's design is done to achieve high efficiency across different load conditions and input voltages. So this is the MATLAB diagram that we have created on Simulink. As you can see, the high side and low side MOSFETs are there, and the arrows shows the switching component, and we have a controller controlling the MOSFET switching to get the desired output.
Now the design consideration for piecewise based LLC converter. There are a few points that I'm going to discuss about. The number one is switch selection. Carefully select the switch semiconductor for the piecewise operation. Consider the switching speed, rating, thermal characteristics of the switches. The second one, the control circuit design. We have to develop a control circuit that can efficiently control the piecewise operation of the switches, implement appropriate timing and synchronization to maintain resonant condition. The third one, the transformer and the capacitor arrangement. Design the resonant transformer and capacitor arrangement for the piecewise based LLC converter. Ensure proper impedance matching and resonant frequency. The fourth one, the efficiency optimization. Analyze the switching pattern and optimize the converter design to achieve high frequency while minimizing switching losses. EMI considerations. Address electromagnetic interference issues resulting from multiple switching events in the piecewise operation. Implement filtering and shielding techniques as needed. So this is the design consideration for the piecewise LLC converter, in which this is the MATLAB diagram, so which was designed and after that implemented on Microsoft Visio, and you can see.
So this is the performance comparison for efficiency The MOSFET based LLC converter typically achieves high efficiency due to the use of MOSFET as the primary switching device as compared to the piecewise or the abstract switching device. As seen in the graph, the difference is not much. So, for um, simpler applications, we would be considering piecewise based instead of MOSFET based. Uh, but for higher load or moderate loads, MOSFET will be uh, better as it exceeds efficiency of 90%.
Okay, Abhinav. Now the efficiency comparison with the piecewise based LLC converter. The efficiency of piecewise based LLC converter largely depend on the efficiency of the smaller switches used in piecewise operation. By distributing the switching duties among multiple smaller switches, the piecewise approaches aim to reduce individual switch losses. However, the increased number of switches and the complexity of control circuits may introduce additional conduction and the switching losses. Achieving high efficiency in the piecewise design requires careful selection of the switches and the precise control of their operation as compared to the MOSFET. And here, as you see the results of the output and the reference voltage, as we can see, the red line denotes the output voltage, and the dotted line with the black color represent the reference voltage. The first, our output voltage goes above higher than 40, and after that it remain constant as shown in the figure. And the down figure is about the switching frequency, which we can see it is high maximum and between 0.2 second to only 1 second, and after that it decreases down.
The MOSFET based LLC converter generally exhibits good transient response characteristics. MOSFETs offer fast switching speeds, allowing the converter to respond quickly to load changes. Proper control circuit design and soft switching techniques contribute to minimizing transient spikes and ensuring stable operation during dynamic loads. The inherent characteristic of MOSFET support efficient transient response in a wide variety of applications. And I've seen like this the simulation done for varying quality factors, and the one with the highest efficiency is chosen.
Now the transient response for the piecewise based LLC converter. The transient response of piecewise LLC converter as compared to the MOSFET depend on the control circuit's ability to coordinate the piecewise switching operation of the multiple smaller switches. The piecewise operation can introduce additional complexities in controlling transient behavior, especially during rapid load changes. The synchronization and the timing of the multiple switches require careful design to achieve a smooth transient response, as shown in the figures. The first figures about the comparison of abstract and detailed model, and the down one LD MOSFET switching frequency. The blue color in the down figure tell about the detailed switching frequency, and another one the abstract frequency.
Switching frequency and electromagnetic interference are crucial factors in evaluating the performance of DC-DC converters. They impact efficiency, component stress, and compliance with electromagnetic compatibility standards. So let's compare the both of them in terms of switching frequency and EMI characteristics. So MOSFET based LLC converters typically operate at moderate to high switching frequencies as compared to the piecewise, which can operate on lower frequencies. But the switching frequency actually depends on the specific application and the design requirements. Due to the fast switching of MOSFETs, these converters may generate higher level of harmonics, contributing to increased EMI emissions. With careful layout design, filtering, and shading techniques, we can mitigate EMI and ensure compliance with EMC regulations.
The piecewise based LLC frequency and EMI. The switching frequency. The switching frequency of piecewise based LLC converter can be tailored based on the selection of the smaller switches and the piecewise operation control. These converters can achieve high frequency switching frequencies. The EMI characteristics. The piecewise switching operation can reduce overall EMI emissions by distributing switching events or multiple smaller switches. EMI mitigations. Although the piecewise operation can help reduce EMI, careful control design, layout consideration are still necessary to manage the potential EMI issue.
Now the last one is component stress and reliability. MOSFETs used as primary switches experience moderate stress due to their inherent fast switching characteristics. However, they are designed to handle such stresses within their specified ratings. Also, MOSFETs are mature and widely used semiconductor devices with proven reliability. So their design and thermal management can enhance their operational life. Piecewise based LLC converters, the stress on multiple smaller switches can be distributed and reduced compared to traditional MOSFETs used in the MOSFET based converter. The reliability of the piecewise based converter is influenced by the reliability of individual smaller switches and the control circuitry. Proper selection of switches and robust control strategies are essential to ensure reliability. In conclusion, the comparative analysis of MOSFET based and piecewise based DC-DC LLC converters has provided valuable insights into their efficiency, transient response, EMI characteristics, and component stress. Uh, the MOSFET based converter excels in proven reliability, stable transient response, and high efficiency at moderate loads. On the other hand, the piecewise based converter offers potential efficiency gains and reduced component stress, particularly at high frequencies and high loads. The choice between the two converters should be based on specific application requirements and trade offs. This research lays the groundwork for future advancements in power electronics, driving innovation toward more energy efficient and sustainable solutions. That's all. Thank you so much.